Okay, I think we are in live. Um, if I think we are in live. Okay, good morning, everyone, or good afternoon. Let's start. Um, Let me open the browser. Okay. Yeah, so just a quick review. Let me know if anyone is on online, if my audio and the display is okay. If someone can confirm, I would appreciate that. Or else we can just start again. So as I mentioned, as a quick review, the web application is about running the application in a remote location using the server, and it will have the server and the client architecture, and the interaction would happen through internet using HTTP request, application level protocol, and use TCP/IP, and you connect using an agent that's on the client side browser, and you will interact with the server. It will receive content in terms of HTML documents, and the user agent at the client will display the content that we receive in terms of markup language HTML. And on the web server side, you will have a stack such as typically the popular LAMP stack, in which it will have the um, server that can route to particular endpoints that's based upon the REST API, different endpoints for different kind of API calls. Yeah, database for saving the information persistently to make it as a stateful application. And then we have the um, OS under beneath, which we call in the LAMP stack as Linux, Apache, uh, MySQL for the database, and the P stands for PHP. Yeah, server side scripting language to manage the application. It's my is it okay? Couldn't see my okay. Sorry. So um, and we saw the different types of attacks, injection attacks. That's the major thing for the web application. And we saw in the previous two lectures the command type injection, SQL based injection. And for today's lecture, we will go over the cross site scripting, in which the injection would be of the type of scripts, HTML scripts, JavaScripts, from the client based scripting, but it can affect both the servers and the clients. So these are the one of the top 10 major vulnerabilities are attacked as per the OWASP's 2021 um, report. You can see for every 4 years they are doing it, and we went over in the last two lectures the client side, the document for the web page, that's a HTML, to learn about the HTML and the type of vulnerable attacks that we can make from these things. And then we went over SQL, which is the database which has to be there for to to serve the application that's persistent and a stateful application. And we also hinted upon what are the impact of any vulnerabilities from the application with the example of how to rob a bank. So this is called CSRF, or cross-site resource forgery type, that we will see for today also. And then we went over the SQL query also. So this is one of the two things that we mentioned, that the vulnerability can be from the client side and also from the server side. And since it's a web, uh, that it gets fully connected, every document gets connected with every other document. It process the any kind of arbitrary data will possess a serious risk, and we have to be wary of what kind of vulnerabilities, and be proactive to avoid any kind of threats and vulnerabilities. And then we went over the SQL queries, and we looked over different queries languages. SQL is a domain specific language, and server can use any kind of database, but the query language would be the same. And so using we saw some of the methods that we can use deploy if there is a vulnerability to get hold of the database. Yes. So we went most of our lectures on the injection type of. We started with the injection type of injection attacks, or uh, injection attacks, starting with the OS type of injection attack, command injection attack. So it happens when the server applications uses the OS type of calls, and either it can call the systems directly, or it can span over the shell and then pass the application that it wants to get the process for as the type of the arguments. And we saw the potential risk that it has. For example, we saw with the example of simple date calling, in which if you pass the if the server application expects the time zone and pass it over the time zone, we can get to know that it's being get executed, and then you can inject whatever kind of things that can be injected, we can inject into it, and then uh, we can do whatever we want to do. So for example, as an example, I just showed using cat, you can read the contents of the password file that would be in the root, etc folder, or else the shadow folder, or else once you get hold of the root, you can do whatever you have once you get hold of the OS, and get the privilege, escalated privilege. And other kind of injection would the script injection. Yes, I'm sorry. Thanks for letting me know. So I was just concentrating on the which, and I missed it. Thank you. Thank you. Yes, so we saw the other kind of injection is the HTML type of injection that we will be seeing it. So you would be able to inject a script if the document or server is expecting an input from the user, and then with that chance you would be able to inject a script in the place of any kind of text, and you would be able to get control towards the page that's being displayed in the client side. And then the third one is the SQL type of query that we spent much of our time in the last time. Uh, for example, in these slides that we are viewing, you can, so here the database stores the username and the password, and then we can get away with giving the password by using this R command. Because of that, so the R command will make the where conditional to be always true, and you are able to get the information or get inside the OS. So this makes it to retrieve any kind of data for this query. You can do whatever things you want, uh, like we saw in the SQL in the previous slides. You can delete the table, you can retrieve other kind of information also, um, uh, drop the table, and other kind of possibilities are there once you know how to get inside the SQL because of the vulnerability in the SQL type of query that we pass. And also we mentioned something about union, I think. So we, if we haven't mentioned, there is also called specifically called union type of attack, in which in the where conditional you can use union and then uh, add another query to retrieve with the same kind of columns, uh, and you would be able to retrieve a different kind of information that's being expected from the binary website, but you can use the union statement and then you can retrieve any kind of things that you would be using it in your challenges uh, of using the union, uh, how it makes it possible to retrieve the information that's not quite expected as per the information expected from the user. The other one is the one that we have already seen in our previous modules on assembly language and reverse engineering, in which we smash the stack uh, and override the contents. And for example, in this kind of thing, we are once again. So let me see that which is getting updated or not. I didn't see the slides being updated in the Twitch. Can someone in the online can confirm that whether they can see the slides being changed? I could see that the slide remains the same on the Twitch. Just it's working now. Okay, so we saw the stack type of injection, and then where we can be able to override the return address, and then from that we can able to run our own arbitrary code once we are able to get hold of the stack and then override the return address. So that's what we saw so far in the OS command type and the SQL type of injection. Uh, in in the in for today we will be going to see about the cross-site script injection. Uh, Before we go over some of the challenges, we will go over the challenges of the SQL type of injection and also the cross-site scripting injection. Before that, we need to go over the important concept on same same site policy and the uh, cross-site resource access policy. So that would be the main topic for today. And as you might be aware, it's it the due date is on 7th on Tuesday, I think. On Wednesday, we will be probably I can cover a part of it, but we will be starting with the next binary exploitation from the next class. So we'll go over the final part of the module, which is the same origin policy, which is an important one. As I mentioned earlier, so this is the web application in which the content that you are deliver would be connected to every other things, and you will have the reference to an external site. You would be using the service of the external site, or the content would have you would paste the content of the some other external site to your resource, and the HTML document would be served as a document object model by the browser, and using the script you can able to make the content dynamic using the scripts, and you can manipulate all the elements of the HTML document. So the cross-site scripting is the one in which uh, the content of the HTML on the client side would be modified because of the malicious injection of the malicious script inside the HTML content. Before that, we have to understand that what's the cross origin policy and how it's so important that it makes this web browsing important. So, this is for example my.asu.edu. For example, the our homepage of our university. It will have the all the contents like image, simple text content, uh, and it will have the reference to the external resources. It won't be limited only to ASU. It can, for example, pwn.college is the external to the my.asu.edu, and it can have the links to any other sites that we are not aware of. For example, google.com, Google sites, the Microsoft sites, or any other sites that can be created by, for example, the student's profile. So, for example, in the example that we are seeing here, this is the web content, and this document is being generated by, for example, ASU server in our ASU campus, and it has the links. It has two link image on the top, and it links to the source of a different site, for example, Microsoft, with the link to HTTP, and the clicking the image can make a get request to the red server. The blue server also, this there is another image called blue, and it can also get uh, send request on clicking the image to the blue server. So as you can see here, so you can have contents from the other people. So that's the normal. That's why we have the web content providing rich experiences. But the blue content can restrict the access by content from the other resources. For example, it can restrict such that the restriction can happen using cookies. So it will authenticate the users, and it can restrict if it cannot be able to provide the cookies. Once the cookies is provided, it can provide the cookie. Uh, but as you can see here, uh, the image or the particular element here, using the script, you can able to control all the contents, all the contents across all the uh, elements. Uh, and if this image belongs to, for example, a script that can manipulate the content of the ASU, then that would make it uh, uh, bad. So your own serving of the content would be disturbed by, yeah, some other element that has been fetched from the some other element. Assume that this image was being fetched from the some other element and replaces this image to a different one, or else the above element shows the, for example, the calendar, exam calendar of the ASU, and this script being retrieved can able to change the content on the above on the red color image. So that would make bad, that would that would make it the current functioning of the internet to be problematic, or may not be possible or useless. That's why at the beginning itself, in 1995 itself, the Netscape, uh, e- either they came to know it or predicted it. They the browser would make the browser implement a policy called same site origin policy. So what's the same origin policy is that the browser can allow the request only if it originates from the same origin. So what we mean by origin is this content that we saw here, it's from the gray color, for example, myasc.com. It cannot make request to an external and retrieve the responses. So, for example, you see here, it can make request to the um, red color server, but it won't be able to retrieve the responses. And also the concept is that any content served by the this gray color item will not have the script from the other one, cannot modify the DOM objects of this gray color item. So if the blue color one is something of an external script, or if it is from another tab, and if there is a cookie supplied by this red color one, the blue color one may not be able, would not be able to modify the access the cookie. So this sending of the cookie would be automatically sent by the browser. Once it first get connected, it will have the interaction, for example, with the gray color one. So it would have some cookies related with the gray color one, but and if the gray color cookie pertaining to the gray item survey is there, the blue item, if that belong to a different source script, cannot get access to the cookie. So that's the important concept that we see here. So the concept is that script belonging to a different source or different origin cannot modify the other contents and would not able to retrieve the response by making simple request. It's possible to send the simple request, but it won't get the responses from the body content. So what do you mean by origin? Origin means the if the document is from the source of the scheme's host and the port, that the triads or tuples of this scheme, the domain and the port is called the origin. So for example, in the http exam.com, the http is the scheme, example is the site or domain, .com is the domain, and example.com you can say as the host of the domain and the host, first top level domain, and 80 is the port. This unique triad constitutes an origin. So if there is anything If there is anything different from this triad, then it won't give access to modify for this a different origin. So if you are viewing a document belonging to example.com with the port 80, the other one that we saw below cannot be able to modify the DOM object of the previous one. Why? The second one, anyone have the ideas? Is the second one is the same origin? Yeah, it's there. So for example, it's on the path alone differs, so it will allow, for example, if something retrieved from the cat.gif, it will allow it to be, if suppose the retrieval is of the uh, script, it will allow that script to change the any of the element of the previous one. uh, 1 second, yes. I saw something like in the Twitch of is this live, and I hope that currently it's in live. Okay, yeah. So the example that comes, it would be able to modify. And how about this? This cannot, a script from this item or cannot modify the content of the element of the example.com because the schema is different. Or else, if there is an image in the document retrieved from example.com, that image directly post or send a get request, it can be able to send the get request, but the response that is retrieved will not be able to this document of belonging to https example.com in the site will not be able to access the response. What about this? This also belongs to the different origin because the example.com is the top level domain. So the cats.example belongs to a different domain. Example.com and the the subdomain would not be considered as the same origin. What about this? This is a different port, so it's not belong to the same origin. So any request or script from this origin would not be able to modify the document DOM, or it wouldn't be able to retrieve response from the external source. Other request. So that's the same origin policy. You can you can get an idea of how critical it is. So it's basically to avoid uh, sites being attacking each other. So that's the explanation given for the same origin policy. If we allow the other content inside the, for example, a image source that we keep here to be able to download or retrieve the some scripts in the response and able to modify the document, uh, it would not be possible. So it's kind of attack from the different sites on your own content. So this is a policy enacted by the browser. So the browser doesn't allow the response to be delivered to the uh, requesting source. What would happen if it's not? So if it's not a trusted browse, then it's possible for to modify different content or whatever would be the possible by malicious script, then that would be possible. So that's why the banking site and other things need the user to have trusted user agent or browser, or else for example you design your own application in which is not a browser, then this won't hold. So it's a policy followed by the browser so as to make it authentic for the true content delivery of the web and server. So, and as you can see here, the simple requests are allowed. So we will allow the request to be sent, but the response, for example, for the get request, you send a get request and you want to get to know, for example, retrieve, for example, a script, or you want to retrieve some data to be displayed below the image. This won't be displayed. The response would not be delivered to the requesting script. the DOM object that initiates the API, fetch API, or the script that usually the script would send the XML HTTP request or the fetch API, modern API. That would not be, the response would not be delivered, so it won't get the response back. Any questions so far with the same set origin? Okay. Yeah, so that's the same set origin. So any other link to the external source will not get the content also. So for example, if there is an image and if it likes to send a get request accessing the cookie, it cannot read the cookie. Um, so for example, here this is the domain name, and this is the top level domain. We call top level domain as the rightmost .com, UK, and college. These are the top level domain. Sometimes you may need to access the domain, so you may have the subdomains. And as per the same origin policy, the cookies cannot be read by the subdomain also. But you may need, for example, cookie may not be for authentication. Cookie would be for site settings, or else the preferences and site settings of the user data that's critical for to make the same kind of experience across the domains and subdomains. And so the cookies has to be shared across the domains, that we will see here. So this is usually the top level domain, and you can see here what are the top level domain. .com is a top level domain, .uk is a top level domain, and .uk and .co.uk is a different kind of top level domain. Similarly, .college is also a top level domain, like .edu. .io is a top level domain, and .github.io is also a top level domain. So what we mean by the site or the host is that the domain plus one, for example, example.com or else pwn.college.github.io. So github.io is the domain, and pwn college is the domain plus one or top level site. So that's the host in that triad of tuples of the same origin. If this is different, for example, the subdomain, for example, dojo.pon.com, the same cookie cannot be accessed by the content from the DOM object belonging to the dojo.pon.college. It cannot access the cookie. So if there is a cookie that has to be persisted for dojo.pon.college to make the user experience same. So for example, the number of challenges you have completed so far, this subdomain may not get access it. And so to enable these kind of possibilities, we can use the uh, cookie attribute. So along with the cookie attribute, when did the cookie will get set? As soon as the first time you contact the site, the server will send the set cookie, and then along with the set cookie, it will send the cookie attribute also belonging to this. There is an attribute called same site, and you can make it something like a none, lax, and strict. So, for example, if you have to use some cookies that will store, for example, the site experiences, how many sites he has already visited, some important cookies that's essential to provide the comfortable navigation across the sites, then and if this sites has to be shared across the subdomains, you can mention along the when during setting the cookie, you can make the attribute same site to be, for example, lax. So if there is a lax, it can be sent to cross site also. Um, Only if there is, for example, if it is a banking domain and if it's set to strict, then uh, the cookie cannot be shared even by the subdomain. So as per the recent, I think Chrome policy, they make it so these are the this can be the policy default would be the policy enacted by the Chrome browsers, even though whatever the setting can be happen from the server. So as per the recent Chrome and Firefox, the default would be the lags. So so you can see here. So if unspecified, the default would be it can be shared. For example, the default the lags, it can be shared across the subdomains. So that's the default. But if we have to set as a strict, then it will be it will the browser will limit sharing the cookie, and any other domain object will not be able to access it. As you can see here how critical it is, like we saw in the banking application, you would be able to insert an image that can link to the external site, and possibly read the script that can read the cookie and pass on the cookie information to the external site. And there is an attribute called path cookie that means to any path or subpath. So you can see here, this is the one in the MDN resource that can show different one. So along with the set cookie, this the server will send this also in the header. You can see here the same site to be strict lags or none along with the cookie value. So that's the same origin policy and about some facilities that we can avail for sharing the cookies uh, with the same set origin policy. And then even with this also we still need some more facilities also to have a efficient uh, deployment of the application to more facilities to the users. So for example, in this in this API world, you may have to incorporate third party APIs in which you would communicate not through a simple get request using asynchronous request, AJAX request. And so the type of request that would be shared between the third party may not be a simple request that's usually permitted by the same origin policy. So the same origin policy will restrict the other kind of communications which are not of simple HTTP request. So what to do if it is? So for example, you are providing a site and you have the APIs with Google Analytics that can give information about the user or something, and you can immediately get to know about the user. And based upon the user preference, you want to display a different kind of thing. So uh, uh, or else you are inside the different document, for example, and you want to contact a different one. The the browser will not permit it. So to enable to sharing the resources, we have this new, not new, this the policy called cross origin resource sharing. So in cross origin resource sharing, the server itself will permit using some kind of the strategy that we will see called pre-flight request, that will allow for specific sites to give access to the specific resources. So we will have the thing called pre-flight request, similar to the cookie that is being set at the time of initiation before getting access. So if you are interested to use the third party cookies, you will initiate this process into your site, in which before the communication you will send the options. Anyone knows what is the option request? So the option request is also yeah, HTTP request in which there won't be a, it won't expect any response similar to the header request, and it's initiated before any request to let the server know what are the methods that it is available. So that's the option you might have seen in the talking the web module that we saw before. So, to use this cross origin resource sharing, in which the server allows uh, the other kind of DOM objects to utilize its own content, the requesting uh, source has to first send the options using these options request with the headers involving its origin and the requesting method and the requesting headers. So, and the server will respond with the methods that so it will respond with the 204 for no content, and it will recognize for, the origin. So that means it will say, so it means that only with that origin, not with the subdomains, is allowed to share the content. And the methods, so at the request it will send the methods also that it wants get access to, for example get and post or other things. So this will recognize for those methods and the headers, and it will also probably may provide additional tokens as credential to be used for subsequent calls. So 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 once this has been received by the client. So the next request would originate from the source. The next kind of request, the script can send the request, for example, using the same methods and the headers that is applied previously from the server during the pre-flight transaction using options. And it will receive, for example, next time the server won't reject, it will send the response, and I'm sorry, yeah, so once it has been the pre-flight has been authenticated, next time it can receive the 200 OK response with the contents also, and the browser will allow this content to be accessed to the source. You can see, so MDN is a very good resource to go over all the content. You can see here the, so if this is of a different origin, uh, same origin request is always allowed, but this is not allowed normally. But cars enables you for have a good experience in the application. Cars enable you for different requests, the request originating from a different source also. So for example, this red color is from a different source, and the web server allows this transaction because of the cause. And the procedure that you can see here, you make a pre-flight request using options, and it will send the response with 204 with the credential, for example, and the allowed method. It recognizes the methods supposed to be allowed, and it recognizes that the request will be allowed only for a forward.example. And so the browser the next time can uh, allow the source to get access to the responses if the source is forward.example. So that's the thing. So the same margin policy, it's very restrictive. Cost enables to have uh, rich uh, uh, facilities or thing happen by using the pre-filled mechanism. It can the server can determine what are the sources that it can share, and because of that, you can make cross-origin request and get access to the resources. That's essentially the important fundamental things about the same origin policy and cross origin policy. uh, this you have to get to know if you are thinking we are in the security, and if you are, or else if you are considering the security of kind of attacks, you should be already know about the policy already in place by the servers, the same origin policy and cross origin resource sharing policy. And the attack has to happen in spite of this thing, and the attacks happen in spite of this, the safety mechanism that's been already enacted in the browser. That's the cross site scripting. In the cross site scripting, in spite of this, uh, the you are able to get access to the information and make the content displayed at the server client side uh, different or malicious. Uh, that's the cross site scripting that we are interested. And the next challenge is about. So let me interrupt here. Any questions with this? So so if I have a, so the example that we saw, for example, like a query for the example that we saw, like a banking a rob, can it be possible, for example, to send a request to, as per the cross origin policy, same origin policy? So this is the some example that we saw. Would it be possible? What happens? Sorry, one second. Okay. No, if it's a phishing site, so for example, the user clicks the link, it will get initiated, and if the link is of genuine of bank, then usually the bank link will send. That's what we already discussed. So the request will be sent only the, if this belongs to something different, not the cross origin policy. That's what I wanted to say. So that's also we are going to see for today's challenges. One of the challenges is the challenges. One of the attack is the cross-site resource forgery attack that we will see here. So it's something related to that. Let's go over the challenges. Did anyone have any query with related to the SQL query that we discussed so far? I have a questions here, I think. Thank you. Yes, exactly. Yeah, the options command is for determining which methods would be utilized uh, for the server client interactions. Item, yes, I'm not catch up with this. And I think last week we looked at the SQL vulnerabilities. One of them would be, we saw from the four, I think, the vulnerability of login, in which you can use the XR command to use, for example, to retrieve the password. So the challenge is about, you have to retrieve the password. And as I mentioned, in these challenges, you have to read over all the code to understand what the challenge is about. And also, the title of the challenge will tell you, for example, this title is about uh, the login query. So you will get to know that this is a SQL injection and it's pertaining to login credentials. And I think this we already, looked at it, but just since I have already opened, we can go over it again. So it says that um, it's it's just create a table here, and then if the retrieved method is a post, and if it is a valid field that's available for the username and password, it creates a session, and then uh, it creates a session. Basically, that's why for the redirect happens. And then if it's a valid password, then it will return the password as the response. And the level 5 would be to level 5, and level 6 is about leaking the data. um, So I think we went over the items such as how we can retrieve something other than the one expected, any kind of information from the table uh, using uh, the SQL type of attack that we saw. So, for example, here it creates the table with the flag and the flag, and then you can see here it uh, it's expecting a query in a request parameter, and it passes exactly the query as such. So it doesn't sanitize or it doesn't use the parameterized query, and it just pass over the query into the SQL query. And so we can use something we saw in our SQL query, like a R type of attack may not be possible, R type attack, and we saw something union attack to retrieve other columns. So you can employ something similar to that to retrieve the password, which is something different. Union query with the SQL query, I think up to 7 or 8 is the SQL queries. This is about yes. So this is also about the query, but the thing that you find it here is that uh, it creates a table name of unknown table name. Uh, so as per the challenge, you will not, as a hacker, you will not be able to know the table name. So you should know how I can retrieve the table name. And we saw something similar to schema. So you can use the how to find table names and the schema that we discussed already during the lecture session, and you would be able to get to know the table. So we'll just move on after the quick indication of how to do with the SQL, and then we will go over the cross script kind of attack that we will see quickly. And for level 7, I think you can see here of blindly leaked data. This can be possible to retrieve using union type of attack also, but the intention here is that you have to know the password, and then you have to retrieve it by you will not be able to know whether the password work, and then you have to try the password, whether the random password that you set is correct, and then trying out the whole password, and then once it gets clicked through, you would be able to display. As you can see here, the so you have to get to know about you can use the union flag that, but the the intention would be to retrieve the password and then use the password, guess the password using the different kind of characters that you have, because it checks for example, the expectation is that um, yeah, the expectation is that the password, and then it has to retrieve the password. So you would use, for example, uh, here where it passes the user ID as the one. So here, uh, so you have to use the guessing kind of strategy alone, other than the union method, to get to the right kind of session. I mean, so other than these two type, it's not possible. Going to the other one, the cross-site scripting. Okay, so you can see here, for example, it's expecting echo, and it's expecting. So what do you see here? So it's the server is expecting uh, the request with a path of echo, and whatever is getting as the parameter of the path of echo. If it is not there, it's displaying, or else it's return HTML echo. So you will see the HTML echo is nothing but whatever the content is pasted, it's been supplied as part of the content inside the body content. So it will be displayed in the HTML page, and then they visit, it will receive a URL, and this URL is make a request using the Selenium, and visit the URL with the echo command, and we see here it's being once once the site has been sent, it will see that uh, if there is an alert here, only if there is an alert, then it retrieves the flag. So the challenge expects you to make you to to introduce an alert in the in it call to the browser. So it's going to visit the URL, and then in that URL it is expecting an alert, and if the alert is there, then you will get a flag. Do you know how we can do that? We can do that using HTTP request that's initiated from the uh, parameters that you pass on the request. But if it is a display towards the script, for example, in a browser, it would not be possible. So, for example, I can introduce a script, for example. So, it's expecting something like a script here. So, how can I do the script? So, the visit just, so if I do the visit, for example, um, I can open the browser here. Let me quickly go over it. So, it's basically expect something like a challenge dot, and then it expects something like a echo. Uh, so it simply pastes the echo, and the visit, for example, so URL equal to, so it expects, for example, challenge dot localhost only. So I have to insert only localhost. Let me see if I have missed something. I think this will be encoded by the browser for the script, I think. So you can see here, I think this is the previous one. It's able to go here. So here the response you are seeing here. Uh, you can see 404. That's, yeah. You can see here the 200 being received here. So it's working, but you have to make it alert, and that's what the challenge is about. So you can use, for example, that's the what we are saying about the cross scripting. Cross scripting is just, so this cross scripting is you are trying to inject a script into the otherwise benign or trusted websites. For example, in the current document itself, and you make it to display or any other different kind of a thing that make it to happen. Would it happen if it is a cross? If it's the same origin policy is being enacted? It will not do. So you have to find a way to do it happen. This can happen probably because of the inputs that's being expected from the user, and in that input you can insert a script, and by that way you can bypass the strict same origin policy and the crossover resource sharing. So this policy has been bypassed probably using the facility of the input, and in that input you are going to insert the script. So for example, if there is an insert and that's being passed as a parameter, if this is sent as a script, it would not be possible. But you can see here it's going on 200, so I can see in that script I can use the echo, and in that echo I can use a script, something like a tag of script to enact the script. And then here you usually the alert is the script for opening the alert with the number of seconds. um, so it's expecting in 0 seconds. So for example, I can see I can give 3 seconds. This will exactly echo inside the body. That's what you would see in the HTML request. This HTML will place the content without any sanitizing the content into the body in the HTML. So you would see, I think I copied it in the here. So this is the full content. If you read, for example, here, how many? Yeah, we have 5 more minutes here. So you can. It's essential that you read over all the content here using cat challenge, and this is the content, and the HTML just places the code here. So whatever we supplied here in the alert, that will be placed there. And if I enable here, it should work. I think the alert should be some content. Yeah, you can see here. Uh, the thing is that you are injected some code, so this code can be something different also. So you if we have sent the request to the website, if there is a website and you are able to send a request. So for example, there is a text box here, and the clicking of the text box or inputting it with this script, you can have the, for example, get element by id, and particular id in the on the topmost corner, you display something here, that, for example, the cookie itself, it will get displayed. So or here you get the script is getting executed, so you can read the cookie also and display it in the content itself. This is made possible in spite of the secure mechanisms of cross origin policy and other things. That's because uh, the script is getting executed in some other way, so we didn't initiate it from the same document. So if it is clicked from the same document as the here, it would not be possible, but we just entered it through the address bar here. And so the I meant to say that this request exactly cannot be initiated from the document DOM object inside the URL inside this HTML document, because of the cross same origin policy and a cross origin resource sharing. Any questions so far? Let me see if I have. Can't say anything. I'm sorry. Hope you got the point. We have similarly. So the idea here is that cross origin policy, so same origin policy restrict the malicious script being enacting to do malicious activities, but still if the server is not careful enough to sanitizing the input, you would be able to execute the script and the client side getting affected by that. So the next challenge would be the main one. We are in ninth challenge. Is that right? Yes. So the ninth also would be the same, but I think the placement of script would require you to think over it. It may not be simple as placing it in a body. It would be expecting the input in a specific kind of the element, for example, text element, and so you have to find the way of making the alert similar to the one that we did, but the content would not be placed in HTML uh, code like here. It could be expecting the code to be placed in a specific element inside the HTML document. So the this one would be is also the script that expect you to do the user action from the sites. And the next one would be the forgery, the cross-site forgery attack that we that usually the cross-site forgery attack happens. So this is also a script, but the user action happens from inside the document. The cross-site forgery attack, the action happens by forging you as the valid user from an external cross-site. If it has been, I'm not sure why the. Okay. Yeah, here the topic would be to uh, here the topic would be something of you are able to make the action user action similarly by using the thing that we use using visit. You can able to visit into if you can see here there is something called a leak in which it will set it to be one that makes it the session to be valid. So you can use the visit to go into the leak and then make it work here. So that's the thing. So this is something related to the action that you want the user to be enact some action to do it for you. So here the leak relates something of an action that being done, and you are foregoing it beyond the same origin policy using some script. So this can be done using a script if that is possible using a text box. So, for example, in the text box, like we saw before, you enter a script that it calls the leak. Since it's initiated from the same origin, this will get executed, and you will see the challenge of thing being displayed here. And the next level would be to do it from the outside. So you have to use, for example, a call from the external source, and from that source you have to call it. So that should be the basically, and then we are out of sight. Probably we'll go over the last three challenges next time before we start binary exploitation in the next class. Thank you. If there is, let me know if there is any questions before we close this session. Let me see for the online. Okay. Thank you.